Okay, everyone. First of all, you're probably wondering, wow, Mrs. Lovett actually made a video. I did. And I'm going to try to make as many as I can for this semester, but it's not a guarantee. So let's start off with, hey, we're in trig! Woohoo! All right. So the first section of trig is just, it's going to, for the most part, remind you from integrated 2 and integrated 3. We're just basically doing right triangle trig, so it's going to be a review. I'm not going to spend a lot of time on this first part because you should remember what the ratios are. Okay, let me change this down a little bit. There we go. So we have sine, which is opposite over adjacent, or excuse me, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, it didn't print out very well here, but we're also going to talk about the reciprocal ones. So, sine of theta is, like I said, opposite over hypotenuse. Its reciprocal is cosecant. And that is hypotenuse over opposite, or 1 over sine. Okay. Cosine again, remember, is adjacent over hypotenuse. Its reciprocal is secant. Which is hypotenuse over adjacent, or 1 over cosine. Okay? So technically cosine is also 1 over secant. Sine is 1 over cosecant. And then the last one is tangent. Tangent is opposite over adjacent. Cotangent, which is right here, is the reciprocal of it. Okay? And you're going to need to have these memorized. Now, I know you have sine, cosine, and tangent memorized, but probably not secant, cosecant, and cotangent. And a little trick to help you remember that I try to tell students is and this only works for sine and cosine. Because students are like, I don't remember if it's secant or cosecant that goes with them. If it starts with an S, the reciprocal is going to start with a C. So cosine starts with an S, its reciprocal is going to be secant because it has to start with the S. Now cotangent and tangent, they both have the word tangent in them. They're pretty straightforward. But for sine and cosine, if one of them starts with an S, then the other one. So now let's continue. Now they're also complementary cofunctions. All this means is if I take a right triangle, I have a 90 degree here. This is theta. That means that this angle up here is 90 minus theta. Okay, because the triangle has to add to be 180. And so whatever theta is, the other one has to be 90 minus that. Okay? And if I look at our sides, if I say this is A, this is B, and this is C, well, the sine of theta would be B over C. Well, that would be the cosine of 90 minus theta. Okay? All right. It's the other one for the other angle. Nothing really major there. All right? So let's find the exact values of these 6 trig functions. Well, first of all, hold on, I got to get my calculator out as it loads. All right. Okay. There we go. I need to find the missing side here. So I'm going to use Pythagorean theorem. 15 squared plus 8 squared is going to equal c squared. All right. So 15 squared plus 8 squared is 289 equals c squared. Take the square root of both sides. Now, if it's not a perfect square, you're going to need to leave it as a square root. Second square root of 289, and that's 17. Okay. So I need all 6 trig functions. So that means I need the sine of theta, I need the cosine of theta, and I need the tangent of theta. I'm going to start with those ones. Sine, you remember, is opposite over hypotenuse. So opposite is 8 over 17. Cosine is going to be adjacent, which is 15 over 17. And tangent is opposite over adjacent, which is 8 over 15. Right? Now to get the other 6, it's just the reciprocals. So if I'm doing sine, sine starts with an S. That means its reciprocal starts with a C. So CSC, cosecant of theta. And I'm just going to flip this over. It becomes 17 over 8. Cosine starts with a C, which means its reciprocal starts with an S. So that would be secant of theta. And again, I'm going to flip it over. Tangent, its reciprocal is always going to be cotangent. And again, I'm going to flip it over. And that's all we need to do, guys, is you're going to find all 3 sides of the triangle, and then you've got to be able to find all the 6 of your ratios. Now, what happens if I give you something that's not a perfect square, or a Pythagorean triple, as this is called? What if I give you something like this? So this is theta, and I say that this is root 17, and let's see here. Let's do let's not do 17. No, let's do 5 and 3. Okay? And so again, we're going to find the hypotenuse. So 5 squared plus 3 squared is going to give me c squared. So that's 25 plus 9 equals c squared. And that's 34. So the square root of 34 is not a perfect square, so I'm going to just leave it square root of 34. Now I have to do all the remainder. I find all my things. And you're not going to be asked to simplify or rationalize with square roots unless it's part of the unit circle, and we haven't got there yet, so you don't need to do that. You can if you want to, but you don't have to. So sine would be 5 over root 34. Cosine would be 3 over root 34. And tangent would be 5 over 3. Like this. So then that makes, this starts with an S, so its reciprocal is going to start with a C. Cosecant of theta would be root 34 over 5. Secant of theta would be root 34 over 3. And cotangent of theta would be 3 over 5. Okay? All right. go on to the next page. All right, sketch a right triangle corresponding to the trig functions. So, and then find all of them. So we're basically doing this off of a graph. We're going to be using first quadrant for right now. So everything's going to be in the first quadrant, but later on that's going to change. So I'm just going to sketch this. All right. So I'm going to make a right triangle here, going from the origin up, and the angle is always going to be with the x-axis. The angle always goes with the x-axis. So remembering that sine is opposite over hypotenuse, that means my opposite side is 5, my hypotenuse is 6. And now I'm going to find the third side of my triangle using Pythagorean theorem. Pythagorean theorem is going to come in all over the place in this, guys. All over the place. I need to find this side here. So I can label it as, since it says the x-axis, I'm going to label it x. And I can say x squared equals 36. Let me go back a little bit. 6 squared minus 25. Or, why do I keep doing that? Minus 5 squared. Well, that's 36 minus 25. And that's 11. So that means that this side right here, along the x-axis, I'm going to take that square root, is going to be the square root of 11. And now we're going to write all the remaining trig ratios. Well, I know that the sine of theta is 5, 6, and you don't have to rewrite the sine, but you can. That means cosine of theta would be adjacent, which is root 11 over 6, and then tangent of theta would be 5 over root 11. Okay. Now doing the reciprocals. Well, the reciprocal of sine is cosecant, and that would be 6 over 5. Reciprocal of cosine is secant, and that's going to be 6 over root 11. And the reciprocal of tangent is cotangent, and that would be root 11 over 5. Okay. Now let's do this next one. And it says secant of theta is equal to 3. Well, we're going to do a little, so secant of theta is basically 3 over 1. And I like to always switch them to the main 3. So if I get a secant, a cosecant, a cotangent, I like to switch it back to ones I'm used to. So this one starts with an S, which means my reciprocal is going to start with a C. So the cosine of theta is going to be 1 over 3. So I'm going to flip this over. I'm going to make my triangle. Cosine is adjacent over hypotenuse, so 1 over 3, and there's my theta. Find the missing side. So this one I'm going to call y because it's along the y value. Y squared is going to equal 3 squared minus 1 squared. Well, that's 9 minus 1, and that is 8. So y is equal to the square root of 8. Okay. Finding all my ratios. So the sine of theta would then be square root of 8 over 3. The cosecant of theta would then be 3 over root 8. Okay. Well, cosine I found earlier, and that was 1/3. That was just taking the reciprocal of secant. Secant is 3 over 1. Now I need tangent, and that's going to be root 8 over 1, which is just root 8, and cotangent, which is 1 over root 8. Okay. We're almost done. Use the given trig function values in the trigonometric identities to find the indicated. So the tangent is 3/4. Okay. So in a triangle, same thing. This is theta. Opposite side's going to be 3. Adjacent side's 4. Well, I know right away this is going to be a Pythagorean triple, and that means that this side is 5. It's a 3, 4, 5. Now, cosine of theta is going to be 4/5. Tangent, well, we already had tangent, so let's just change that to cotangent. Actually, I'm going to change it just something a little more complicated. So let's say I want the sine of 90 minus theta. Okay. Well, 90 minus theta, remember, is one of our cofunctions. This is the angle here that's 90 minus theta. 90 minus theta, the sine of it is the same as the cosine of theta. Well, the cosine of theta would then be 4/5. Cosecant is the reciprocal for sine. So it's 1 over the sine. Well, 1 over sine is going to be 3/5. So it makes that 5/3. Cosine of 90 minus theta is the sine of 90 of theta, which is, the sine of theta would be 3/5. Okay. Angle of elevation, angle of depression, these have not changed since integrated 2. Angle of elevation is from a horizontal or a flat surface going up to look at an object that's higher than it. Angle of depression starts from a higher object going down. Okay. And these are going to be used in word problems, and you're going to have quite a few. Some other information, just as a reminder, a whole bunch of stuff from integrated 2 is going to come back. Alternate interior angles, vertical angles, all of that's back. Okay, so you need to keep track of those things. All right, so we have a word problem here. A biologist wants to know the width of a river. Let me make sure that this is the end of the notes. To properly set instruments for studying the pollutants in the water. From point A directly across the river from point C, the biologist walks to point B and sights to C. And the sight is determined to be 58 degrees. How wide is the river? Verify your results numerically. Okay. So we're looking for that. Well, since it's directly across, that means that this is a 90-degree angle. So that means that the tangent of 58 degrees equals W over 100. Cross multiply, so 100 times the tangent of 58 equals W. Use my calculator. Make sure your calculator is in, where is it? Degrees. Okay. So I want 100 tan of 58. And that gives me 160.0334. Now what it wants to verify your results numerically is you can use this now, like go inverse a tangent of your angle of the side length divided by 100 and see if it gives you your measurement. There's a couple different ways. But your work here is enough also to verify it. All right. So that's the end of our first chapter. I'm going to double check. First section. If you have any questions, just let me know.